Right, I'm back again. I have 4 resistors in parallel. The only ones I could get is 3 10 watt, 10 ohm, and the fourth is 10 watt as well, but that is 33 ohm. So the overall resistance is probably around about 3.3 ohms. I think I worked it out to right. Which means I should get around about 1.5 amps across the transistor. So let's just try it all out. Let's check out the temperature and everything. It's only on. As you can see, 5 volts, 1.6 amps, but remember you got a minus 100 milliamps for powering everything else. It's at 19 degrees at the moment, which is all good. Just to show you again, same setup. There's my temperature probe attached to it, which obviously then goes to that, which all the little malarkey things are at the back recording it. Okay, so there's the start of it. I'll come back in 5 minutes and just check what temperature will be then. So 20, there you go. So back in 5. Okay, the other thing I want to do to show you just how many volts have been dropped across the collector emitter is, see, I've got a probe here, which is going to my multimeter, which is set for DC. So here's my other probe. I've got it already attached to the collector. So I just need to put it to the emitter, which is that one. And it's 0.24 of a volt, so it's basically 244 millivolts. Now I assumed it was going to be around about that anyway. So I've done a little calculation and it's only about 300 to 300 milliwatts going across it. It's like 0.35 of a watt. Now, as you can see, this thing is rated at 115 watts power dissipation, and at 0.3 of 1 watt, the temperature is still rising after 5 minutes. It's up to 26 degrees now. I'm going to leave it another 5 minutes and just see how far that goes. I mean, I know when they rate the power dissipation, it's probably got heatsink on and fan and everything else. But, I mean, the fact it's not even 1 watt and it's already rising. So, I'll be back in 5 and to check the temperature again. So, see you in 5. Okay, it's been a total of 10 minutes now. It's got up to 28 degrees, which it was 19 to start off with. So, which isn't too bad, but you also have to remember that it's only about 0.3 of a watt going through there. At the most, say 0.4, just to be a little bit conservative. So, let's call it 0.4 of a watt going through there, and the temperature has rose 9 degrees in 10 minutes. Which, that temperature rise is acceptable. I prefer to keep it under 25 degrees because that's when you get the highest stats for all the on the data sheet apparently. So the thing I'm going to try next is I'm going to try and pull a full watt through it and see how fast the temperature rises. I have got a heat sink which I will do, attach it at a later date and then see if that'll keep it cool. But yep, next thing is put a watt through it, which will be the next video. So thank you for watching. One little side note as well is if you do attempt anything like this yourself, these resistors, even though I have 4 10 watt resistors, are very, very hot to touch. I've just tried it and I'm going to turn it off now for the simple fact of they are starting to get a bit too hot. So just bear that in mind if you ever do that, and definitely don't use small wattage resistors as they'll probably burn up. So okay, little warning for you. Thanks.